All right, let's go ahead and get started. So, hopefully you're noticing that all of these have grouping symbols in them. So that's going to mean we're going to have to do some distribution. Like in this first one, you're going to distribute the 2 to both of these, right? And so what we have is 2x plus 10 equals x plus 7. Then we're going to go ahead, we're going to solve for x. Let's subtract the x over so that we've got all the x's in one place. And then subtract the 10 here. And that'll leave us with x equals -3 as our final answer for problem number 1. Yeah? So again, when you're doing these, remember that the first step is always to decide where the x is going to go. If there's an x on both sides, pick a side. It doesn't matter which side, but if there's an x on both sides, pick a side for the x to go, move the other one to that side so that you have everything on one side. And then everything's going to fall through from there. All right? Let's go ahead and do the second one now. All right, so with this one, notice we've got a parentheses on both sides. So we got to distribute to both sides here. Distribute the 2 to the stuff on the left, distribute the 3 to the stuff on the right. Everything within those parentheses. So what do we have? We've got 2 times 4 is 8x plus 2 times 3 is 6 equals 3 times 3 is 9x. 3 times -1 is -3. So once again, let's choose where the x is going to go. Let's take the 9x and subtract it over to the other side. So that leaves us with -x plus 6 equals -3. Let's subtract the 6 over. A -3 and a -6, I already owe you $3. Let me hold 6 more. And now you owe -9, right? Now you owe $9. So now let's get x by itself. This negative has to go away, so we'll divide by -1. And we get 9. Right? Lastly, okay, we only have the distribution on this side, so let's write it out. 2x minus 1 equals 2 times 4 is 8x plus 2 times 5 is 10. So let's subtract that 8x over. I've got $2 in my pocket, but I owe you 8. Once you shake me down for those $2, now I only owe you 6, right? Well, now let me get the numbers over to the right-hand side. And then let me divide. And this doesn't go in evenly, right? So, and the other thing is that 11 and 6 don't have anything in common to divide by. So I really can't do anything with that. What I am going to do is I'm going to leave it that way. -11 over 6. I wouldn't write it as -1 5/6, even though you could. Math Excel probably isn't going to like it. If you want to do it like on handwritten stuff that you turn into me, sure, fine, whatever. But like for what you're doing here for this semester, for sure, why you've got just like, you've got directions, follow them, right? And that's it. There you go. Just like that. Those are your 3. All right, so what are we doing today? We're going to be talking about the centroid and the orthocenter. These are the last 2 spots on the triangle where we're cutting the triangle in half in some kind of way. So the centroid, we're going to talk about that. That is what we call the center of mass. As you go higher and higher and higher into your various math classes, you're probably going to revisit this again because what we're going to learn is how to find the center of mass of a triangle. But, you know, eventually as your abilities become more and more sophisticated, you're going to need those, like, to find the center of mass of any shape, no matter how it looks. And there's calculus for that. And you will talk about that once you get to calculus. More complex three-dimensional shapes, you actually need like a third semester of calculus where they talk about that separately. But we're worried about normal plain old triangles for this, and that's as far as we're going to get for geometry. Finding the centroid of a triangle, and then the orthocenter. We'll talk about what the orthocenter is. Basically, when you drop an altitude, and we'll talk about how to do that and all that. So let's start out here. So a median, that's where we are going from the corner to the midpoint of the opposite side. Basically, the segment bisector coming from the point here. That's what we call the median. And so here's the thing. They have it written out like this, but I wanna point out that, you know, they're gonna be working with any of these segments here. So how do I say this? Well, let's say it like this. So let's say you know, we'll call the centroid, we'll call it C. We'll call this point B. So the bigger piece here from A to C is 2/3 of the way, which means that the smaller piece here, CB, is 1/3 of the way, right? So they only give you the bigger piece to the whole thing, but I want to make sure to talk about all the pieces. So I'm going to do that with you right now. So I'm going to, you know, small, then there's medium, and then there's large, right? So basically the way it works oh, 2 times small equals medium. And I'm going to tell you honestly, between these two, like, you can, like, if you have the medium and you want the large, if you find the small and then you multiply that by 3, you can get the large. But you could also, that's where this one comes in. But I would almost rather say 3 times because the medium one is 2/3 of the large one. So if I take this 3 here and I multiply it up here, 3 times the medium piece equals 2 times the large piece. Again, the only reason that I bring this up and why I want to talk about all these is because working with fractions when you've got algebraic statements is annoying. And why do that when you can come up with ones that don't have algebraic statements, that don't have fractions in the algebraic statements, right? You don't want fractions when you're trying to multiply into like x plus 4. That's a pain in the butt. So by having equations that look like this, you eliminate the need for that. But you could seriously just live off of this one thing and figure everything else out, right? It doesn't matter which way you go. So here, they tell you that XA is 8, and they want to know what's XB. So I'm going to show you 2 different ways that you can do this. It really just sort of depends on you. What they want you to do is they want you to say XA equals 2/3 of xb. That's the way they talk about it here, right? Medium equals 2/3 of large. But really, in fact, if it were me, I would rather say 3 times xa equals 2 times xb. So you could be like, okay, well, I know xa is 8. Well, this is 24. And then divide by 2. And you could do it that way. Another way you could do it is you could be like, all right, well, xa is 8. Ooh. This one is half of this one, right? 2 times the small one equals the medium one. If this is 8, this had better be 4. So what's the whole thing? 12, right? I mean, like I said, it doesn't matter how you go about doing this. There's about 1,000 different ways to do this. It really doesn't matter which way you do it. As long as you get the same answer that I do, and as long as your mathematics is good, you know you're going to be okay. All right, I want you to give this one a try. So instead of giving you XA, now I'm giving you ZA, and I want you to find the length of ZC. Okay, so once again, there's like 2 different ways to do this, and it really just depends on you. You can be like, all right, well, ZA is 9. And I want to find the big one, ZC. So 9 is 2/3 of this. Well, let me times 3 divided by 2, right? So times 3 divide by 2. Or if you prefer, you can just leave it as 27 over 2. Both of these answers are correct. It's just going to depend on what they ask for. Or you could say, all right, well, I know this is 9, which means that AC is half of that. Half of 9 is 4.5. And add all that together. 9 plus 4.5 is 13.5. It's totally up to you. I'm not telling you the way you have to do it. I am saying, however, that, there's multiple different types of people, and they're going to come out with multiple different ideas in their head about what's the easiest way to go. And so, here they all are for you. All right? But either way, you best get 13.5. Or to say it another way, 27 over 2. All right, now let's talk about this fella right here. So once again, what we're trying to deal with or what are called altitudes. So think of the altitude like you're dropping a perpendicular down to the opposite side. Now I want to, when it comes to an acute triangle, it's very easy. You just go from the tip, drop it straight down to the opposite side, make sure there's the right angle. And if you need to, you can turn the triangle around to make sense of how to drop a perpendicular. When it comes to a right triangle, when you try and drop a perpendicular down some of the sides, it's going to be just directly along that side because it's already at the sides are already at right angles to each other. So 2 of the sides are already the altitudes. When it comes to an obtuse triangle, this is the tougher one because we sort of have a situation where the triangle doesn't have enough side to drop down to. Like if I wanted to, let me do us a favor and make a nice obtuse triangle here. We'll go with something like this. like this. So the problem is, okay, so some of these I can drop the perpendicular down. That's not a problem. Like here, this side, right? I can drop that perpendicular straight down. Make them dotted lines. A perpendicular straight down like this, right? But for these other two, it's like, okay, well, if I try to drop, I can't drop a perpendicular down to that side. I can't make it perpendicular. I have to go straight down, right? Because this is a horizontal. So what I'm going to do is I'm going to be like, okay, well, maybe what if I extend this out? Like that. Well, now I can drop a perpendicular straight down like this. So the thing is, the altitude for like this one is going to be here. The altitude for this corner to this side is actually secretly going to be out here. And that's fine. It doesn't actually matter where it is. It's just you got to be sort of aware of that. And like, you know, we've been talking about how this is where all the altitudes sort of meet up. This center here. So if we try and do the exact same thing here, I try and drop a perpendicular down, it's not gonna make it. We have to extend this line. So let me extend, and then I can drop my perpendicular down. And so, like, okay, so here's the extensions of the line, right? Let's see if I can click on both of those at the same time. Is it going to let me do that? Yeah. So these two black dotted lines here are just extensions of the original triangle line. And then these red lines right here, these are the perpendiculars dropped down, right? See how this is perpendicular here? This is perpendicular to this side. This is perpendicular to the extension on this side. And you see they all meet up right here. Right there. And so this is what we're talking about. It's this obtuse one that causes people some consternation because it requires you to like do some extending and stuff, but that's okay. So what I want to do is I want to go back to you. There we go. See, so just like when we were talking earlier on this past Thursday about the circumcenter. Remember how the circumcenter could help you determine whether you had an acute, a right, or an obtuse triangle? Same thing here. The acute triangle is going to have its orthocenter in the middle, somewhere inside the triangle. A right triangle is going to have its orthocenter. Now, instead of being on the hypotenuse like the circumcenter was, the orthocenter is going to be on the right angle vertex. So find the right angle. Boom, it's right there on the corner. And then the obtuse triangle is going to be on the outside on the big angle side, like we saw over here. Right? So that's what we're talking about. So let's do a couple examples real quick. Find the coordinates of the orthocenter. Again, all you have to do is drop perpendiculars down. So let's do that. Let's, from this corner, we want to drop a perpendicular. Well, this has a slope of -3/2, right? So we want it to have a slope of 2/3. So let's go through and find that slope of 2/3. Right? From here like that. Slope of 2/3. So these had better be perpendicular. Right. And then from this corner, well, this is a vertical, so we just want a horizontal line. So that's going straight through here, like that. And then this from this corner, well, this corner is horizontal, so we want a vertical. And look at where everything ends up. Right here at the point 0, 0. And so that's one way of doing it, right? Actually physically drawing it out. Now, in this case, we do have a right triangle. So we actually don't need to go through all this extra rigmarole because we have a right triangle. And remember, if you know you have a right triangle, then you can just go through and say, all right, well, this is a horizontal line, this is a vertical line, this is a right triangle. And since this is a right triangle, I know that the orthocenter is right here on the corner, yeah? And that's all. So it's got the coordinate 0, 0. Go ahead. Give this one a try. Make sure you're capable. Make sure you can do it. Okay, so let's go over. So once again, we've got a number of different ways to go about doing this. We can first figure out the altitude. So dropping from the corner to the opposite side, this is a horizontal line, so we're going to make a vertical line through this. Let's make it look nice and pretty. All right. And then once again, this has a slope of -1. So through this point here, we're going to want a slope of +1. Again, you got to watch out for being nice and neat here. Always make sure that you start directly at your corner so that you know you did it right. Make it match up. Do the same thing over here. Start at the corner. Again, this is a slope of 1, so we got to have this one have a slope of -1. And there we go. And so we have identified where the orthocenter is. It is right here at the point 0, 4. But again, if you as you're going through, you should even be saying, hey, this is a slope of 1, this is a slope of -1. Those are perpendicular lines. Opposite reciprocal slopes. It's a right triangle. This corner has to be where the orthocenter is anyway.